Okay, so we have. I'm the least professional person ever. We have a cue ball right here, right? And we have the red ball right there. This cue ball, I'm going to label P1. I'm going to say the cue ball is P1. Okay, I'm going to call this red ball right here P2. All right? So P1 is equal to some mass, whatever the mass of this cue ball is, times its velocity. This red ball, P2, is equal to its mass. We'll call that mass 2, and its velocity. So mass 1 of velocity 1, mass 2 of velocity 2. These P's actually represent momentum. That's how we write momentum in physics. We just say P. So this is saying the momentum of ball 1 of the white ball is equal to its mass times its velocity. And then the momentum of ball 2 is equal to its mass times its velocity. So right before the instant that this ball hits the red ball, what is the momentum of this red ball? What is that equal to?
0.
It's equal to 0. Why is it equal to 0?
Whatever its mass is times velocity, 0 is equal to 0.
Yeah, the velocity is equal to 0. So P2 is equal to 0 right now. P1 has some sort of mass and it has some sort of velocity, so it has momentum. This brings up the law of the conservation of momentum, and it's written like this. P1 plus P2 is equal to P1 plus P2. Who would have thought? This is really initial, right? Final. The initial momentum of the system is equal to the final momentum of the system. So as this ball, I'm going to erase this, as this cue ball comes in and hits this red ball, we'll play it. The red ball all of a sudden has momentum. So the red ball goes from, so P1 plus P2 goes P1 plus P2. It goes from 0 to some value. I was writing it as X right now. So this P1 has some initial value, right? It has some sort of value. We'll call it 5. 5 plus 0 is equal to blank. As this white ball, as this cue ball hits the red ball, it transfers its momentum into the red ball, thus losing some of the momentum itself. That makes a lot of sense, doesn't it? So this white ball, for instance, might then have a momentum value equal to 2. What does that then make P2 equal to? 3. Very simple, very easy. X is equal to 3. Now, there are two different types of collisions. There is, where is it? Perfectly elastic and perfectly inelastic. Oh, how did I not? I don't have it anymore. All right. Well, that's all right. I don't need this. There's two different types of collisions, elastic and inelastic. An elastic collision is when some ball comes in and bounces off. Perfectly elastic means it loses no momentum. It comes in with some value 5 and it leaves with some value 5. Make sense? That's elastic. Inelastic looks like this. So a ball comes in and sticks to the wall. It goes from 5 to 0. We'll learn more about that later, but there's a worksheet that I want you guys to do that has these questions on it, and I just wanted to show it to you. But remember, momentum is always this. P equals mv. So do the equations, do the problems on the worksheet, that's P equals mv, all right? And you'll get that for homework. Also, for homework, I want you guys to find and film a short 5-7 seconds of some sort of collision, elastic or inelastic, and tell me what it is. So, for instance, I could do this. Elastic collision. So something like that, but you can't use that example. So find something at your house or a video game or anything where you can make a collision happen and tell me if it's elastic, where it bounces off, or inelastic, where it sticks to it.